the derivative of trigonometric functions. We have learned last class how to do the derivative of a chain function, that is, if y is a function of u and u is a function of x, how will you find the derivative? We said that dy by dx is nothing but dy by du. Y can be differentiated with respect to u, then du by dx. It is like divide and multiply du, similar to that, although it doesn't mean that. Okay, so if I want to find derivative of sin x, what have you noticed? The angle part of sine and the variable of differentiation both are same. Then I have direct formula cos x. Derivative of sin x is cos x. But if the angle part and the variable of differentiation are different, for example, d by dx of sin u, in that case, how will we go about? The theorem says they both are not same, so you cannot differentiate it. Make it same by applying this formula, that is du, another du here, and this dx here. You can see if this du is removed, it's almost same as this. Although it is not division, but you can learn it that way. So derivative of sin u with respect to x is first to differentiate sin u with respect to u, then differentiate u with respect to x. So your answer became cos u into du by dx. This is the way you get this formula. Let's try to understand the formula a little more better way. When I differentiate sin u, that is when the angles are different, when angles are same, directly cos x. When the angle and the variable of differentiation are different, they are not same, not equal, not same. Then what you should do? The derivative of sin x is cos x. So derivative of sin u is cos u into derivative of the angle. So sin trigonometric part changes. The angle part does not change. What was the original angle of sin? U. After the derivative, what happened? The sin became cos, but the angle remained the same. And what extra? Derivative of the angle. Let's have a look at this. D by dx of, let's say, sine of x cube. What is the angle here? X cube. Variable of differentiation? X. Not same. So you should say, when you differentiate sine, it changes to cos. The angle part remains the same. Angle part remains the same. No change. Same. Then, what more? Derivative of the angle part. Derivative of the angle part. So your answer became cos of x cube into derivative of x cube. That is 3x square. That becomes your answer. So whenever we are applying a derivative of a trigonometric function, when the angle and the variable of differentiation are different, the trigonometric part changes, angle does not change, derivative of the angle again. So now it has become very easy for you. Now let's have a look at this. I want to differentiate cos u. So cos will get differentiated, cos x derivative is minus sin x. So cos u will be minus sine, what is the angle here? U. So that remains the same, into derivative of the angle. What is the angle here? U. So derivative of the angle. Derivative of cos of log x. What is the angle here? Log x. What is the variable of differentiation? X. Are they same? No. What you should do? Derivative of cos is minus sine. Angle part, does it change? No. Angle part will remain the same. Whenever you differentiate in a trigonometric function, the angular part of the original function and the answer will be the same, into derivative of the angle. So your answer became minus sine log x into derivative of log x, 1 by x. Do not, usually students, what they do, they will write derivative of cos log x is minus sine. Instead of log x here, they will write 1 by x, derivative of log x. That is wrong. Angle part will never get differentiated. Angle part will remain as it is. But after the function, trigonometric function is over, derivative of the angle has to be taken again. So angle differentiation is separate. It does not come inside the angle part of the original trigonometric function. So let's see another example. Let's say I want to find, just recap first, derivative of tan x. What is the derivative of tan x? Both are same. Tan x changes to sec square x. So what will be derivative of tan of root x? So what is the angle part here? Root x. When you differentiate, what happens to tan? Tan changes to which trigonometric ratio? It changes to sec square. So sec square, what is the angle here? Root x. Will it change? No. The root x will remain as it is. Into, what more to write? Derivative of the angle. Derivative of the angle. So this is a method. So that became sec square root x, angle will never change, into derivative of root x. What is the derivative of root x? 1 upon 2 root x. I hope you remember this. Derivative of x raised to half. What is the derivative of x raised to half? Half x raised to half minus 1. That became half x raised to minus half. That became half 1 by root x. So derivative of root x is directly 1 by 2 root x. This should be by heart. You should not every time do this. Derivative of root x should be directly known to you as 1 by 2 root x. Let's practice a little more. D by dx of sec of sin x. What is the angle part here? Sin x is the angle part. So angle part can be anything, any function can be. What is derivative of sec x? Both are same. Sec x derivative is sec x into tan x. That is the formula for derivative of sec x. So what will be the derivative of sec of sin x? You can see angle and the x are not same. Angle, this is the angle part. X is here. So derivative of sec of sin x will be sec x changes to sec x into tan x. So sec into tan. Sec will change to sec x into tan. Sec angle is sin x. Tan angle is also sin x. Are you happy with this much? No, something more is there because they are not the same. If they are same, we would have stopped with only that much. If they both are different, angle part and variable of differentiation are different, then we have to take the derivative of that angle part again, derivative of the angle part again. When you differentiate sec, sec will change to sec into tan. Original angle part will remain the same into derivative of the angle. So your answer became sec of sin x, tan of sin x into derivative of sin x, that is cos x. This is how you find the derivative. D by dx of u to the power n. Second, we learned derivative of root u. Now we have learned derivative of trigonometric function. Any trigonometric function, let's say tan u. Let's compare all of them. Power rule starts from what? Power rule starts from the power. So start from n. In fact, you should remember derivative of x to the power n. You should remember derivative of x to the power n is n x raised to n minus 1. From there you must start. U raised to n. Start from the power. Reduce the power by 1 into derivative of the base. Start from the power. Reduce the power by 1. Derivative of the base. Derivative of root u. Root x derivative. Recap, derivative of root x is 1 by 2 root x. So what will be derivative of root u? 1 by 2 root u into derivative of u. That means whatever root u comes here as it is into derivative of the base. What is the inside the root? What is there? Its derivative. Derivative of tan, trigonometric function. In trigonometric function, what changes? Trigonometric part changes. Tan will become what? Tan will become sec square. So sec square, what is the angle here? U. It will remain as it is into derivative of the angle. This is what you have to remember. Power rule, root rule, trigonometric rule. Power rule starts from power, reduce the power, derivative of the base. Root is 1 upon 2 root u into derivative of whatever inside the root. Do not put root in for the second time. Then, in trigonometric function, if it is tan, changes to sec square. The angle part remains the same. The angle part remains same. The trigonometric part change. Trigonometric part change. And the derivative of the angle part again. So this is how you have to remember. Trigonometric part changes, angle remains the same into derivative of the angle. d by dx of, let's say, sine cube sine square x. Now you are confused. Which method to apply? You are saying cube. Cube means whole cube. That means power rule. So what will be the method? Start from the power 3 sine square, no change in the angle, into derivative of the base. What is the power here? 3 is the power. What is the base? This whole thing is base. U raised to n. What is u? Whatever the whole base. So derivative of the base. Again, start from the power, reduce the power, derivative of the base. Now that became 3 sine square of sine square x. Don't write into of sine square x. Read it correctly. 3 sine square of, bracket is read as of, sine square x. Now derivative of sine of sine square. Which category is sine of sine square? Sine of sine square, trigonometric category. So sine is the trigonometric part, angle part is sine square x. In a derivative of a trigonometric function, what changes? Trigonometric part changes. Sine will become what? Cos. Cos of sine square x into derivative of sine square x. Now let's have a look at it. Nothing to do with this. This will remain as it is. 3 sine square of sine square x, cos of sine square x. Now comes to sine square x. Which category? Sine square, power category. Start from what? Start from the power. What is the power here? 2. So start from what? 2. 2 sine x. Start from the power, reduce the power by 1 into derivative of the base. So what will be your answer? 2 sine x into cos x. That will be your answer. That's why it's called chain rule. It works like a chain. Every time you have to recognize first whether to apply power rule, whether to apply root rule, whether to apply trigonometric rule. This is how you have to recognize it. Every time you have to ask, as soon as you start the function, which category is the function belongs to. If there is a power, start from the power. If there is no power, start from the trigonometry. If there is a root, start from the root method. This is what you have to learn in this particular exercise. We'll practice few more problems in this. Let's try this problem. We have derivative root of sine root x. I've written all the 3 formulas here. So whenever I want to refer, I'll just want to show you the formula. So root, it starts with a root. So you have to ask a root derivative. What is root derivative? 1 by 2 root. 1 by 2 root. Whatever this as it is. Sine root x. 1 by 2 root u. Into d by dx of. What should I take d by dx of? Without the first root. This root you have differentiated. That root goes away. Derivative of root u, only u. What does u mean? Whatever inside the root. So sine root x. Now let's differentiate that. That will become 1 by 2 root sine root x. Now which category is sine root x? Sine means trigonometric. Trigonometric category. Sine changes to what? Sine changes to cos. So cos root x into derivative of the angle. What is the angle here? Angle is root x. So my final answer became 1 upon 2 root sine root x into cos root x into 1 by 2 root x. The derivative of root x is 1 by 2 root x. 2 into 2 will give you 4. So final answer I can write cos root x will be in the numerator, 4 root x will be there, and root of sine root x will be there. This will be my answer. Cos root x will be numerator, 2 into 2 will give you 4. This root x will come first, then root of sine root x will be present. Now let's have a look at next one. Every time before you start the problem, first thing that you should ask which category is this problem belongs to. Again, the root was not here, the root was whole root. So started from root, whole root. Here started with a sine of something. So if you read this sine of, so which function? Trigonometric function. What happens in trigonometric function? Sine will change to cos. What about the angle? Angle will remain the same, but derivative of the angle has to be taken again. So sine changes to cos. What is the angle? Root cos 2x. Should I change this? No. Angle should remain the same. Into derivative of the angle. Derivative of the angle. So that became cos of root cos 2x. Now tell me, what is the derivative of root cos 2x? Which category? Root. What is the derivative of root x? 1 by 2 root x. 1 by 2 root cos 2x into derivative of whatever inside the root. whatever the base, cos 2x raised to half it is, a base, derivative of cos 2x. Again, your answer will become cos of root cos 2x into 1 upon 2 root cos 2x. Now comes to which category? Cos category. What is cos derivative? Minus sine. What about the angle? Angle is 2x. So minus sine 2x into derivative of the angle. So derivative angle is 2x. Derivative of 2x. So derivative of 2x will become 2. Since I do not have space, I will just write 2 directly here. Now this 2 and this 2 will get cancelled. So your answer will be minus sine 2x into cos of root cos 2x divided by root of cos 2x. That would become my answer. Remember, do not write derivative of cos 2x or minus sine 2x and stop over there. Whenever the angle is anything else than x, if it is only x, if it is a derivative is only x, and with respect to x, you are doing derivative cos x. Your angle is x, derivative is with respect to x, same, only cos x. But here angle is 2x, variable of differentiation is x, they both are different, so derivative of the angle has to be taken again. I want you to again and again observe it. Without observing, you cannot learn this. Every time you have to keenly observe what is the change happening, how to think logically, and then learn. Function. We know derivative of log x is 1 upon x. So what have we noticed? They both are same. What will be derivative of log u? Which means variable of differentiation x, they are different, not same. How will I find the derivative? As usual, divide and multiply with the du. d by du log u into du by dx. Divide and multiply with du like that. Now derivative of log u, 1 by u into du by dx. So here is the formula. Derivative of log x is 1 by x. Derivative of log of anything else, 1 upon anything else into derivative of anything else. Whatever denominator comes, that only answer. Very important. Derivative of log do not contain log. Logarithmic function, when you differentiate, it becomes algebraic function. Derivative of log u is 1 by u. Derivative of log x, 1 by x. There is no log in the answer. So there will be no log in the answer of the derivative. Let's have a look at it. Derivative of log, let's say tan x. So derivative of log x is 1 by x. So derivative of log tan x will be 1 by tan x into derivative of what? Derivative of whatever you write in the denominator, tan x itself. Whatever comes in the denominator, uska derivative फिर से. So 1 by tan x, derivative of tan x is what? Sec square x. So what is your answer? Sec square x divided by tan x. Let's have another example. So once again, let's learn once again the formula. What is derivative of log u? I'm writing over here. Derivative of log u. First to recap, log x derivative. Log x derivative is 1 by x. Log u derivative, 1 by u derivative of u. This is the derivative of log u. Now we are going to practice on this. So let's say I want to differentiate log of log of x square plus 1. Derivative of log of x square plus 1. What is the derivative of log u? 1 by u. So 1 by x square plus 1 into derivative of the denominator. Whatever you write here, it's the derivative, x square plus 1. So 1 by x square plus 1 into derivative of x square is 2x. Derivative of 1 is 0. So 2x upon x square plus 1. Let's another one. Derivative of log of sec x plus tan x. Derivative of log of sec x plus tan x. So what will be my answer? 1 upon sec x plus tan x into derivative of sec x plus tan x. 1 upon, this is your u, this is your angle. 1 upon u into derivative of u, which will become 1 upon sec x plus tan x. Now let's differentiate it. What is the sign here? Plus. So each one has to be differentiated separately. Derivative of sec x tan x. Derivative of tan x, sec square x. So what is common between both? Sec x is common. If you take sec x common, what is inside the bracket? Tan x plus sec x. What is the denominator? Sec x plus tan x. So what you notice, what is the speciality? They both will get cancelled because sec x plus tan x, sec x plus tan x. So what is the answer? Sec x. Very small answer. Derivative of log sec x plus tan x is sec x. Very small answer. So this is to be remembered. Another important function. Y is log of x plus root of x square plus a square. We need to find dy by dx. Remember, every function we start with y. Even if the question is differentiate log x plus root x square plus a square with respect to x, you will have to start with the let to y equal to. This is very important. Although when I'm teaching, I write only dy by dx and directly do the problem because my board is very small. But because of limitation, I do that. But every question you should start with the let to y equal to. That's why when I'm giving you a lot of sample questions. For what purpose is the sample question? So that you can write the solution in the same manner. Because board exam requires you need to write it into the same format. So the format of what I give you an example, you need to do in the same format. Learning you can do in this manner. Learning need to be learned fast because the video has to be small. So I cannot keep on writing everything in very small steps. In the assignment, I have given all the steps which to be written for the board exam. Okay. Now, first of all, I need to find the derivative of log x. So d by dx of log x, log u, derivative of log u. Okay, I'll write one more step. D by dx of log of x plus root of x square plus a square. Which formula to be recapped? Log formula. What is log's formula? Log u derivative is 1 upon u into derivative of u. So what you must write? 1 upon u, u is this whole bracket, x square plus a square, into derivative of, in log what you notice, whatever here, uska derivative फिर से, whatever in the denominator, uska derivative फिर से, log of x plus root of x square plus a square. So your answer became 1 upon x plus root of x square plus a square. Very important. Now each derivative goes inside. I told you this bracket is the most important and most likely mistake for every student. So bracket will remain as it is. Derivative of x 1. Derivative of root x square plus a square. Derivative of root 1 upon 2 root x square plus a square into derivative of what? Derivative of not with the root, without root. D by dx of x square plus a square. Remember, we are differentiating with respect to x. So a square is a constant. So 1 upon x plus root x square plus a square into 1 plus derivative of x square is 2x. Derivative of a square is 0 upon 2 root x square plus a square. So this 2 and this 2 will get cancelled. Now what I'll do? I'll take the LCM. The beauty of this problem is this LCM. 1 upon x plus root x square plus a square into, when you take LCM, root of x square plus a square plus x whole divided by root of x square plus a square. This is the beauty of this problem. They get cancelled. So 1 upon root of x square plus a square. This problem is an important problem because this cancellation. I showed you the two places I showed you a very good cancellation. Log sec x plus tan x. There I showed you. Again, log x plus root of x square plus a square, this cancellation. Problems with such beautiful cancellations are always important, and further we require it in other chapters. Come to the last formula, exponential functions. What does exponential power function means? The power is x. Just compare this both. Derivative of x raised to 10, derivative of 10 raised to x. Algebraic function starts with the power. Exponential function, repeat the question, log of the base. Here 10x raised to 9. Both are different method. This is algebraic, power is a constant. Base constant, repeat it. Base constant, repeat it. So your question now is, what will be the derivative of a to the power u? What do you know? a to the power x. You know, derivative of a to the power x is a raised to x. Repeat the question, log of the base. So a raised to u. First differentiate a raised to u with respect to u. First differentiate with respect to its own variable. Then differentiate u with respect to x. So your answer will be a raised to u log a into derivative of the power u. So what does this u stands for? U stands for power. Whereas each one u has different meaning. Power rule, base is the power. Base is the one which you have u. In root, whatever inside the root is u. In trigonometric function, u is the angle. In log function, whatever log of, whatever the value or whatever the denominator come here, that one's derivative. In exponential function, the du by dx is nothing but the power. So what will be the derivative of phi raised to sin x? Naturally, what kind of function? It is power is base is a constant, not power. So base is a constant. So base is a constant means exponential. Exponential means repeat. So phi raised to sin x into log phi. Repeat the question. Log of the base into derivative of what? Derivative of the power. Power is what here? Sin x. So your answer is phi raised to sin x log phi into cos x. This will be the derivative of phi raised to sin x. Now let's have a look again. Few more questions to practice. So before that, let me write that formula also. D by dx of a to the power u. Remember, a is a number, u is function of x. Repeat it. A raised to u log a into derivative of u. So naturally, one more formula I can add on to it. Same method. D by dx of e raised to u. So only difference is that instead of number a, it is the irrational number e. So your answer will be e raised to u. Log e is 1 because the base of this log is e. Log e to the base e is 1 into du by dx. So in case of e raised to x, we already know derivative of e raised to x is the function itself. There's no change. There's no formula there. Derivative of e raised to x, e raised to x only. But in place of power, you have x squared. What will be the change in the method? E raised to x squared derivative will be e raised to x squared into derivative of the power. So your answer will become e raised to x squared into 2x. So this is to remember. Now 6 formulae you have to learn. First one, power rule. Let's take one example. We will not write the answer, just will one example we'll take and learn it. X squared plus 5 raised to 7. Base is x, power is number. So your answer, start from the power 7, x squared plus 5 raised to 6 into derivative of x squared plus 5. Derivative of x squared plus 5 is 2x, so you get your answer. Now look at this one. Derivative of 7 raised to x squared plus 5. Try to understand the difference between the two. Base is a constant. Base is constant. How to start? Repeat it. 7 raised to x squared plus 5 into log 7 into derivative of the power. When you repeat it, derivative of the power. So 7 x squared plus 5 log 7 into 2x becomes your answer. This is how you find the derivative. Now one more I'll do. Derivative of e raised to let's say tan x, tan square x. Derivative of e raised to tan square x. E raised to x derivative is e raised to x only. So your answer will be e raised to tan square x into, no need of log e. Log e is 1, so we don't have to write log e, into d by dx of tan square x. So what will be your answer? E raised to tan square x. Now derivative of tan square x, which category is it? Trigonometry? No, because there's a power. If it was only tan x, it would be trigonometry. Because of the power, it becomes this category. Power rule, how do you start? Start from the power. Start from 2. 2 into tan x, 1 power reduced, into derivative of the base. What is the base here? Tan x. So your answer will be e raised to tan square x into 2 tan x, and derivative of tan x is sec square x. That becomes your answer. So this is how you find the derivative of the exponential functions. derivative of log x. Remember, first of all, differentiating with respect to x, d by dx of log x. So what is the outside function? Log. Remember, derivative of log u. Derivative of log u is 1 by u derivative of u. So this part is your u, the bracket is u. 1 by the bracket log x into derivative of whatever you write down, log x. Now this became 1 upon log x. Now derivative of log x. Now your u is log x. So 1 by u. So the outside log will go away. Whenever you differentiate log is not present in the answer. Whatever in the bracket comes to denominator. When you are differentiating log of this log will not be there in the answer. Whatever the bracket will come to the denominator into derivative of the denominator. So your answer became 1 by log x into 1 by log x into derivative of log x. This would be your answer. To x square upon 1 plus x square. So first we'll have to apply derivative of e raised to u. E raised to u into derivative of the power u. So your answer will be dy by dx is equal to d by dx of e raised to x square upon 1 plus x square, which will be e raised to x square upon 1 plus x square into d by dx of x square upon 1 plus x square. Now, how will we differentiate this? It is u divided by b. So we'll have to apply the quotient rule. What is the quotient rule? D by dx of u upon v. Start from the denominator, derivative of the numerator minus numerator into derivative of the denominator upon square of the denominator. So if you apply this formula, x square upon 1 plus x square, start from the denominator. So 1 plus x square into derivative of the numerator minus numerator into derivative of the denominator whole divided by the square of the denominator. So that became e raised to x square upon 1 plus x square, 1 plus x square into 2x minus x square into 2x divided by 1 plus x square the whole square. 1 plus x square the whole square. Now 2x square cube, 2x cube will get cancelled, and after the cancellation this will become e raised to x square upon 1 plus x square in the bracket. This 2x cube and 2x cube will get cancelled, only 2x will remain divided by 1 plus x square the whole square. That will be your final answer. So with that we will end today's lecture, and don't forget to give likes for this video.